Today we are going to start a new problem on a square pyramid. So you can see the problem. So you have to construct a square pyramid of dimension 35, base head dimension, 65 mm axis length. Okay, rests on HP on one of its edges of the base. That means we need to construct a square with respect to the edge here. Okay. So first we are going to draw an XY line here. Okay, square of dimension 35, you have to 35 means 3.5 box here. Okay, so here in the slant edges will be thick lines. Okay, because these are slant edges. So I can write A, B, C, D, O, and O. And so I can show the dimensions here on one side. So it is 35. Okay, now projecting. Okay, here axis length is 65. Okay, 65. Take here 65 using the scale. Here. Okay, the front view of a in pyramid, it is a triangle. You know it. Okay, so here B dash visible, A dash not visible, C dash visible, D dash not visible, O1 dash in bracket, and O dash. So here we'll take base edge inclinations. It is 90 minus angle of inclination to HP, it is 45. You can see that. So that is 45 degree. Okay, here take a reference point of C dash and D dash. So using protractor, we want to mark 45 degree. So here angle line. So now using compass, you have to measure this length from C dash to B dash. The first arc, second arc from C dash to O dash. Okay. So you can write here B dash and O dash. This is O1 dash. Okay. Now using compass, second arc from C dash to O dash. So you can join it. Okay, so we have to join here. Okay, so this point we need to join. Okay, and we have this axis. So we have to draw an axis here. So by extending this axis, if you measure the angle, so that will be exactly 45 degree. Okay, so this is O dash. Okay, now projecting the lines vertically downward. A, B, C, D, 1 more. So first we construct outer boundary line. C to O to D and D to E. So this forms an outer boundary line. Now here triangular face B dash, A dash, O dash, triangular face visible from the top. Okay. So it is visible. Okay. Now we can see that this square base not visible from the top. So that's why it is a dashed line. Okay. Then finally we have an axis. So I can show it. Now angle of inclination to VP is 30 degree. I'll draw a parallel line here. Take a reference point. Here I will mark 30 degree. Okay. .30 degree. So this is what the resting is, not visible from the top. We'll take this. Okay. So for the angle line, we are going to draw the angle of inclination line here. Okay. It will be convenient. Current D point. So this is C. Okay. Now from C to B. And D to A. Next it is reverse. At this point it is O1. From D to O. This is O. Okay, now we'll join these lines. So this is dashed line. Okay, and finally we have an axis. Okay, now projecting the lines to construct the final position. Okay. This is O dash. B dash, this point it is C dash, and D dash we have this D dash, and finally we have this O dash. Okay, the concept for constructing the final position in the pyramid is, first we have to construct the base, that is here in the base it is in square. So first we are constructing a square here. Okay, then we draw the slant edges. Say first slant edge I am drawing from A dash to O dash, next from B dash to O dash, third from C dash to O dash. You can see that with respect to this base, if the slant edge is passing inside of it, inside of this square, the base, we can say that that will be n dashed line. Okay. In the dashed line, and finally we have an axis. So this is how we complete the problem. Today we do another problem in pentagonal pyramid. So the problem number, it is 23 in CAD solution book. So in this problem they have given pentagonal pyramid dimension 25 and axis length 50, rest on HP on one of its corners of the base. That means the first position starts from the corner on the right hand side, and then you see that draw the projections of the pyramid here. When the axis of the pyramid, it is inclined to HP at 40 degree and to VP at 30 degree. So angle of inclination, it is there with the axis for both HP and VP. Then it is an beta angle problem. Okay, it's an beta angle problem. So first we construct an XY line here. Okay. First we construct an XY line here. VP, HP. So pentagon we have to construct dimension 25. Okay. Now the angle we have to construct 72 degrees. Okay, 72 degrees. So I'll be drawing a line of length to this. Very also. So now using compass, I will join it. Okay. So pentagon it is constructed. Now perpendicular bisectors we have to do. So for that we will be marking exactly the middle points of all the edges. Okay. So after this, these edges. Okay, you have to keep only the slant edges here. Okay. Keep only the slant edges here. O1. So now we'll project it front view. So for the front view they have given dimension of 50. Okay. For the axis line. So A dash in the B dash, C dash, E dash in the 1 dash, 1 dash, C G dash. Okay. So now second angle of inclination it is 40 degree. So we will go to base edge inclinations. That is 90 minus angle of inclination to HP, that is 40. So we will get 50 degree. So I will take first a reference point of here, D dash, marking it 50 degree. Using compass. First arc, second arc, third arc. Okay. So we will give the names 1 dash, C dash, and D dash. Okay. So we are going to erase this part using compass from D dash to O dash, first arc. Okay. Next again from this B dash to this. So now we have to join it. So there is an axis here. And there is a straight line. Okay, so we are going to extend this axis, and we can show the angle here hitting exactly 40 degree. So projecting downward, okay. O dash, we can write the namings here. A, B, and this is we have 1, and C point is this is D, this is E, and this point is 1. Okay, so D is not visible. So first we construct an outer boundary line. Okay. Outer boundary line. Now the triangular face, this A dash, B dash, O dash, visible from the top view. It is triangular face. So A, B, O, it is visible from the top view. Okay, now this is pentagonal base, not visible from the top view. So part of it we are going to show with the dashed line. Okay, then we have finally from here to here part of the axis, so I can show. So this is a bit angle problem. The first axis length we have to use this, and second axis length we have to use this. So how much we are getting this? This is around 40 mm. Okay, 40. So now it is in beta angle problem. First, so I can take here, draw a line, and here reference point. Angle of inclination, that is 30 degree. Okay, first reference point I will take, that is O, measuring 50 mm. Is O2, then one of spine. Again we measure from O. This is 1. So we will get the angle between here. So we are getting an angle of 41 degree. Okay, so now you have to copy the diagram. So this diagram you have to copy here. Look at this diagram. So we have 2 points here. You can see that on the same point, same line we have O1 to D. Next from here, O to D and O to C. Next from this D to this point we have C. This point we have G. This is B. So we are going to join it. From here to here, this is dash line. So we are going to show with the dash line only here. Okay. Now we have to project it upward. O dash. O dash. O dash. C dash. G dash, and finally we have this is A dash. One dash. So how to construct the final position? First we construct the base of the pyramid, right? That is base. Here we have pentagon. So pentagon we will be constructing. Okay. Okay. Now we have to construct the slant edges. With the slant edges passing outside, that will be continuous lines. You see that from V dash to O dash, C dash to O dash. You can see from here, from E dash it is passing inside, also dashed line. Similarly from this D dash also, so it is passing inside of it, that's why dashed line. Finally we have an axis, so we can show an axis. So this completes the problem. We see a different type of problem in pyramids, that is slant edge and slant triangular face. Okay, in this type of problem they will be not mentioning second angle of inclination, that is inclination to HP, they will be not given. Instead of that they will be mentioning slant edge, resting on the slant edge and slant triangular face. In this problem another thing is that they also don't mention the first position also. So how to identify the first position? If they mention slant edge, means the first position will be starts from the corner. Okay, if they mention slant triangular face, means your first position starts from the edge. Okay, base edge. So this is how you have to identify in the slant edge and slant triangular face. Remember, they will be not mentioning second angle of inclination to HP. Instead of that they will be telling resting on the slant edge or slant triangular face. And they are not mentioning the first position also, it is resting with the base edge or base corner. So we have to identify from these words. Say slant edge means first position starts from the corner, slant triangular face means first position starts from the edge. Okay, so problem number 24 from CAD solution book. So in this problem it is a problem from projection of solids. You can see in this problem what they have given: hexagonal pyramid of dimension 25, sides of base 50 mm, axis length they mentioned, rest on HP and one of its corners of the base. So first position start from the corner, okay, with respect to the right side, such that two base edges. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degree and appears to be. You can see that if they are given appears to be means no beta angle. Okay, no need to find out the beta angle. Now we are proceeding with the solution. So first I am going to construct XY line. Then after that I am going to construct VP, HP and Y. Here you can extend this. So here first position starts from the corner. So dimension 25. Mark it 60 degree. So we have to mark it 60 degree here. I am drawing a line of length 25. Okay. Again we have to mark at angle 60 degree. Again drawing a line of length 20, so 24. So again we have to and join the line of length here. Now finally, so we can join. So we can show the dimension on one side. Give the naming A, B, C, D, E, F. Now drawing the slant edges here, inside lines has to be thick lines. Okay, inside lines has to be thick lines in case of pyramids. So remember it. So in case of prism, we are drawing the thin lines to find out the center of the axis. Okay. This is O and O1. Now projecting the lines. So from here we have to draw an axis of length 50. A dash, B dash, and F dash. This is O1 dash, C dash, and B dash, and D dash, and this is O dash. Now, first we are going to take B dash here. So here we write base edge inclination. Okay. So base edge inclination is 90 degree minus angle of inclination to HP given 40 degree. So 90 minus 40 means it is 50 degree. So we have to incline this at an angle of 50 degree. Okay. First star, vertical. Second arc. Third arc. Fourth arc. So now you have to write the namings. A dash, C dash, F dash, O1 dash, C dash, B dash. Now measuring from here, so if you measure this angle, you have to get exactly 40 degrees. So this length we have 50 mm. Okay. So this is O dash. Now projecting downward. So we have to construct an outer boundary line first. Okay, outer boundary line. So first we have to construct the outer boundary line here. Okay, now these edges are visible. Okay, F2 is also visible and this also visible from top view, but this base it is not visible, so that's why it is written with the part of it is written with the dashed line. Okay. Again from D dash to O dash that is also not visible, so dashed line. And then A to O, that is also visible. You can see that A dash to O dash also visible. Now take a reference point. So angle of inclination to BP 45 degree. Take that. So it is 45 degree. So appears to be problem. No need to find out the angle. So first is the O point. Now measuring from O to A. First measuring from O to O1. Okay, measuring from O to O1. Next measuring from O to D. So these points we are getting D. So D point is not visible. This is O1 and this is A. Okay, we have 3 points here. A to F. Okay. Then reverse it is from here D to and you can see that this length also same. It is from D to E. So we can join S, E, B, C. So now we write the final position. Okay.
Tilak, Sumut, Harish ಬಂದಿಲ್ವಾ? Harish DNA submission ಯಾವಾಗ 23rd 26th last date. ಇವತ್ತೆಲ್ಲ ಕಂಪ್ಲೀಟ್ you take all this coordination of that and complete make it ready. You have to get it the signature from the principal and your hatra.
chairman or secretary and
ಅದನ್ನೇ ಮಾಡಿಸಿದ ಫಸ್ಟ್ ಯು ಟೇಕ್ ದ ಪ್ರಿಂಟ್ ಔಟ್ ಆಫ್ ದಟ್ ಪ್ರಿಂಟ್ ಔಟ್ ತೊಗೊಂಡ್ಬಿಟ್ಟು ಏನೇನು ಕಂಪ್ಯೂಟ್ ಆಗಿದೆ ಅದು ತೊಗೊಂಡ್ಬಿಟ್ಟು ಎಸ್ ಅಂದ್ರೆ ಈಗ ಸಬ್ಮಿಟ್ ಮಾಡಬೇಕಲ್ಲ ಸಿಗ್ನೇಚರ್ ಅದನ್ನ ಅಕೌಂಟ್ ಸೆಕ್ಷನ್ ಸೈನ್ 25% ಅದೇ 25% ಕಾಲೇಜಿಂದ ಹಾಕಬೇಕು ಸ್ಯಾಂಕ್ಷನ್ ಆದರೆ ಅಂತ ಈಗ 25 ಲಕ್ಷ ಸ್ಯಾಂಕ್ಷನ್ ಕೊಡ್ತಾರೆ ಕಾಲೇಜಿಂದ 25 ಅಂದ್ರೆ 25 ಕೊಡ್ತಾರೆ ಅಷ್ಟೇ. ಸೊ ಯು ಆಲ್ ಆಫ್ ಯು ಶುಡ್ ಬಿ ರೆಡಿ ಬಿಕಾಸ್ ದೇರ್ ಇಸ್ ನೋ ಟೈಮ್. ಇವತ್ತು 23 ಇವತ್ತು ನಾಳೆ ಒಳಗಡೆ ಸಬ್ಮಿಟ್ ಆಗ್ಬಿಡ್ಬೇಕು ಅಷ್ಟೇ. ಆಗಿದೆ ಸರ್, ಅದು ಚೆಕ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡ್ತಾರೆ. PPT ಮಾಡಬೇಕು, ನಿಮ್ದು PPT ಮಾಡಬೇಕು. ಇವ್ರು ಬೇಕಾಗಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಆಲ್ರೆಡಿ ಇವ್ರು PPT ಕೊಟ್ಟಿದ್ದಾರೆ. PPT ಇನ್ ದ ಸೆನ್ಸ್ ಏನಾಗಿದೆ ಅದೇ ಸೇಮ್ ಥಿಂಗ್ ನೀವು ಏನು ಮಾಡಿದ್ರೆ ಅದೇ ಸ್ವಲ್ಪ ಹೇಳಬೇಕು, ಈ ಥರ ಮಾಡಿದ್ದೀವಿ ಸರ್. ಪ್ರಿನ್ಸಿಪಲ್ ಎಸ್ ಅಂದ್ರೆ ಇಲ್ಲ ಅಂತ ಅದು ಇಲ್ಲ. Just you have the responsibility for this one. You have to take care of the dividend. They have to complete it today and tomorrow. ಇವತ್ತು ನೀವು ಹಾರ್ಡ್ ಕಾಪಿ ನನಗೆ ಅಲ್ಲಿ ಹೋಗಿ ಸೈನ್ ಮಾಡಿಸ್ಕೊಬೇಕು. ಸೈನ್ ಮಾಡಿ ಇದಕ್ಕೆ ಪ್ರಿಂಟ್ ಬೇಕಲ್ವಾ?
This completes the problem. You can like the video, subscribe for the channel, and hit on the bell icon. So now we are going to discuss problem number 31 in CAD solution book, question bank solution book. So this problem we are starting with the slant edge. Okay, you can see in this problem we have to construct a square pyramid of dimension 35 and axis length 50. So rest on HP on one of its slant edges. As I mentioned, if they given slant edge means our first position starts from the corner. Okay, first position starts from the corner here. Okay, your first position starts from the corner here. Draw the projections of the pyramid when the axis, you can see when the axis is given, and they are also mentioned appears to be. So if they mention appears to be, no need to find out the beta angle. Okay, appears to be if they given means no beta angle. Okay, no beta angle. So here in we have to construct a square of dimension 35 with respect to corner. Here slanted means for corner we have to start. Okay, first I'm going to write an XY line. Okay, so VP HP. Right. So first I'm going to take a reference point here. Somewhere here I will take. Okay, here I will take reference point, and I'm going to mark 45 degree on both sides. Okay, 45 degree. And here also 45 degree. So now I'm going to draw a line of length 35 from this end. Okay. So 30, 35 here I will end. Similarly here also. Okay, so it is done. So now using compass, measuring 35. So we are going to cut the arc. So it is around here getting. Okay, so we can give the name A, B, C and D. So we will write the slant edges here. Slant edges we have drawn O1, and we can show, we have to show the dimensions here. So now I'll project it upward to complete the front view. So front view axis length we have, it is 50. So A dash, B dash, C dash, but D dash not visible, O1 dash also not visible, O dash also not. So in this problem we have to make it this resting on the, this is our slant edge. You have to make it this slant edge resting on this xy line. Okay, that's what the problem here. C dash, from C dash to O dash you can put the arc. The O dash, again from C dash to E dash, so we are going to cut the arc. Then again from this O dash to E dash. Okay. So we are going to join this. Okay. This is E dash. So this is O dash also here. So now we'll project it downward. So you can write the names. This is A, B, C, this is D, this is O1, and this is O. First we construct the outer boundary line. This top face, it is visible, okay, square, it is visible from the top view. Sorry, this is E dash and this is C dash, this is C dash. Okay, this see that E dash, this slanted edge, it is visible from the top view, so it is continuous A to O, but from this C dash it is not visible. Part of the we are showing the dash line. Okay, so it is now it is appears to be, so appears to be means no beta angle, so we have to place it the reference point here. And then we have 55 degree. So first we will take reference point of O here. Next from O to C we have to do. You go to C. I see this from C to O1. Then O1 to E1. In the same line we are having it. E1 and this is A. Now putting the arc. This is D, this is B. So now we can join it. Part of the dash again you can show here. So now final position, dash, dash, C dash, and finally we have 1 dash. First we construct the same concept and pyramid. First we construct the base of the pyramid. Okay. No slant edges. It's passing outside. And this also passing outside. And this also passing outside. But from here, T dash to O dash is passing inside. That's why dashed line. And finally, we have axis. Okay, so this completes the problem. Another problem in from the CAD solution book on the slant triangular face on the hexagonal pyramid. You see in the problem hexagonal pyramid dimension 25 and 15 axis length given. Thus on one of its slant triangular face. So slant triangular face means our first position starts from the base sides or the side. Okay. So draw the projections of the pyramid when the axis appears to be. So axis appears to be means no beta angle. Okay. So when the given appears to be means no beta angle. So here first we have to construct an hexagon with respect to edge here. So edge we have to construct hexagon with respect to edge. So 25 dimension. So marking at 60 degree. So 25. Here again. So you have to mark it 60 degree. Okay. Again we have to mark 60 degree. So 25. And again here, so marking it 60 degree. So finally we have so constructed second A, B, C, D, E, F. Now the slant edges. Slant edges we have drawn. So here. So 25. Okay. It is O1 on the front view. So front view axis length we have 50. So naming dash not visible, B dash, C dash visible, F dash not visible, D dash visible, E dash not visible, O1 dash, O dash. So on the slant edges, so we have to mark D dash and E dash. So measuring the length from compass from D dash to O dash. And from D dash to A dash. And again from the O dash to A dash. Join it. O dash, C dash, F dash. Okay. Now drawing the second position top view. So writing annotations here. This is E, this is D. This point we have C. And this point is B. This is A. And this is F. And centrally this one O1. And this is O. So first we are constructing an outer boundary line. Okay, so outer boundary line is on, and hexagonal face it is visible from the top view. So actually this is connect here with this part, and this is D. Okay. So and this triangle of A dash, B dash, O dash visible from the top view. So it is a continuous triangular face. Okay, this bottom face, you see that with this bottom triangle of face, E dash, D dash, O dash, not visible. So that's why it is written with the dashed line. Okay. And finally we have an axis. We will show an axis. So no bit angle here. So because appears to be, they have mentioned angle of inclination to VP is 45 degree. So take a reference point of O. Next from O to O1. So we can cut the arc. This is O1. Now using from O to A, exactly the same length. So here we have to cut first arc, second arc. Next from O1 to A and O1 to B. So this is A and this is B. Okay. Now we have O to F, constructing hexagon. So here from this point we have dashed line. So final position we have to do so dash. We have A dash here. This point we have A dash. This is A dash. This is B dash. C dash. This is 1 dash. So first we are going to construct a hexagonal base here for the pyramids. Slanted this. Okay, here two slanted edges from F dash to O dash. It is passing inside, and from here A dash to O dash also passing inside. Finally we have axis, so we can show the axis. So this completes the problem.